Back in the 1940s, a computer was this colossal machine that would literally fill an entire room. But today, you're holding something thousands of times more powerful right in the palm of your hand. So how on earth did that happen? Well, we're about to break down the 5 massive leaps in computing that made it all possible. Let's dive right in.
Right. This is the big question, isn't it? How did we go from a room-sized machine to a pocket-sized powerhouse? The thing is, it wasn't just one single invention. It was a series of 5 revolutionary breakthroughs, each one building on the last. Let's take a look at the timeline to see how it all unfolded.
So our whole story spans a little over 60 years, and we can break it down into these 5 distinct eras. We're going to start in the age of these giant vacuum tubes and journey all the way to what's happening right now with AI and even quantum computing. Each of these generations represents a fundamental, game-changing shift in what a computer could even be.
Okay, let's start at the very beginning, in this era of absolute giants, where the idea of you or I owning a computer was basically science fiction. This is the story of that very first great breakthrough.
So these first-generation computers ran on things called vacuum tubes. I want you to picture thousands of these delicate glass bulbs, and each one is acting like a tiny, super slow light switch, just flickering on and off to represent a single bit of data. This was the massive, power-hungry heart of all early computing.
But, and this is a big but, these vacuum tubes had some major problems. They were huge and clunky, which is exactly why the computers were enormous. They were slow, they kicked out a crazy amount of heat, and they were just, well, they were unreliable. If a single one of those thousands of tubes burned out, the entire machine could just grind to a halt. Something had to give.
And the solution? It was the transistor. This tiny little solid-state device completely replaced that bulky glass tube. I mean, it was a fraction of the size, used way less power, and was just worlds more reliable. Honestly, this single invention is the reason computers started to shrink, period.
So, inventing the transistor kicked off this incredible chain reaction. The next 2 generations were really all about one thing, cramming more and more and more power into smaller and smaller spaces. This is how technology finally ended up right in our hands.
The next leap was all about efficiency. I mean, think about it. Why would you wire up every single transistor one by one when you could just print them along with all the other parts onto one tiny little chip of silicon? This was the birth of the integrated circuit, the IC. And this didn't just make computers smaller. It made them exponentially more powerful and way more affordable.
Then came the 4th generation, which took that whole idea to its absolute limit. Instead of just putting some components on a chip, engineers figured out how to put the entire brain of the computer, the central processing unit, the CPU, onto a single piece of silicon. And that, my friends, was the microprocessor.
And this was the breakthrough that made personal computing a reality for all of us. The microprocessor is the engine that powers your desktop, your laptop, probably the phone you're holding. This is the innovation that brought the power of computing to everyone.
And that brings us to right now and to the future. We are smack in the middle of the 5th great shift, and it's a big one. We're moving beyond computers that just follow our instructions to creating machines that can actually learn and think.
This right here is the core ambition of the 5th generation. See, we're not just programming computers with a bunch of if-then rules anymore. We're building machines that can learn from incredible amounts of data, that can recognize patterns and make decisions, a lot like we do.
The 2 main pillars of this new generation are, of course, artificial intelligence, which is everywhere now, and the mind-bending potential of quantum computing. These technologies are set to solve problems we used to think were completely impossible. So look, if you take just one thing away about this current shift, let it be this. For 60 years, we built machines that were unbelievably good at calculating. Now we are building machines that are learning how to think. It is without a doubt the most profound leap yet.